Welcome to ClickMyProject.com. Our product title is Allocation of Distributed Generation using proposed DMSP approach based on utility and customers aspect and deregulated environment. Now we are discuss about our product abstract. Many methods were proposed in the literature for finding best allocation for DG placement considering various objectives. Sometimes it becomes task for system planners to select the objective for DG allocation based on utility and customer point of view. For this purpose, a set of optimization functions and sensitive factors has been developed for allocations of DGs in the systems. The optimization method consists of maximum loadability, minimum losses, and cost while satisfying power system constraints. The sensitivity factors comprise the voltage performance index and low loss sensitive factor for DG allocations. A decision made by system planners approach has been proposed to decide the allocations of DG in this system based on utilities and customers' demand. For this purpose, first DG allocation have been planned in this system based on various objectives. Then suitable objective has been deducted from the utility and customer necessaries by DMSP. Having this in order, DMSP and analysis hierarchy process has been used to take the decisions over getting the approximate location for DG placement in the system. A combined suitable options for DG allocations with equal weightage to the various objective has also studied in this work. The basic objective of electricity supplies industries to meet the demand imposed on the optimal, secure and efficient manners. The energy demand is increasing rapidly due to the very huge industrial and population growth. Generally, the ESIs are planned to supply the growing demand up to the certain time period. Now we are going to discuss about our product flow diagram. This is our flow for as system architecture. Our mainly what the purpose the DJ placement for this bus system, for example 24 and 30 bus system, we are getting for example 10 bus and 40 DG's placement. So how one transmission to another transmission, the planner utility one DGs. The DG is a distribution generators. The generators to transmit the power, how to get the power loss and cost, and then the voltage and the ranking of the bus system, which bus is giving the most transmission power and voltage. So the minimizing the losses, maximizing the loadability, loss reduction sensitive factors, and the planners of the customer's own DGs, the voltage improvement performance index, and minimizing cost. This is our main objective of these flows. This method has been demonstrated and analyzed the IEEE 24 bus reliability test systems. The IEEE 24 bus system consists of 10 generators and 24 buses and 38 lines. The simulation has been carried out of the matter of integrated development environment and export the choose of the softwares. And this in the case the impact of the integration DG systems loadability has been observed without any DGs in the network, and the maximum system loadability has been found. The optional location and DG placements have been identified with the crystal maximization system loading. With the integrations of DGs has been served and loadability of the system increase. The maximum system's loadability has been determined the 5 available of DGs with optimal locations. The line flow in the case without and with DGs lines in the given observed the power lines and deduct the remaining the 2 and 3 DGs is presented. Now we are going to discuss about our the running procedure. So this is our development tool for MATLAB 9 version, and we are developed. This is the main function coding the MATLAB, the power systems, and then this is the data set for the bus system. What is bus system for 24 bus system, and then line data, bus data. So we get the input from this MATLAB functions. Now we are running the main program. This is the coding for the RTS bus system for DG placement systems. So now we are initialize the data sets and the PGs, voltage, DG, generator cost. This we have coefficients of the generator cost functions. This is total cost functions, and then this is a total system loss, power loss, and then this is a LSF. So they are giving the input for data sets. So now we can just running the procedure. So how the get 25 bus system distribute the bus, and the another DG is distributed that other transmission line. Which bus is the optimal location is the best total system loss. So which bus the bus system best is we can graphically analyze it, and then we can see the voltage performance index with the DG capacities, and then this is the VPI values ranking load buses with DG placement. So which bus get the more voltage power. So 0.6 is the very high voltage. So we are getting the ranking systems. So graphically we are analyzed the output functions. So optimal locations.